Have you ever looked at the back of a semi-truck and noticed that strange metal plate connecting the truck to the trailer? It doesn't look very impressive. There are no giant motors. No huge chains. No massive hydraulic arms. Just a thick piece of steel sitting behind the truck cab. But that one simple part is responsible for pulling loads weighing up to 40 tons every single day. Without it, modern trucking would completely fail. Every supermarket, gas station, construction site, and warehouse depends on this system to move products across entire countries, yet most people never even notice it. So how does this small-looking part survive so much force without snapping apart? Why doesn't it crack when a fully loaded trailer suddenly breaks? And what would happen if it failed at highway speed? Today, we're going deep inside one of the strongest parts ever placed on a truck, the fifth wheel coupling. And once you understand how it works, you'll never look at semi-trucks the same way again. What is the fifth wheel? The fifth wheel is the giant metal coupling mounted on the back of a semi-truck. Its job is simple: connect the truck to the trailer, but in reality, it does much more than that. This one system must carry enormous weight, survive vibration, handle twisting forces, absorb road shock, survive sudden braking, allow turning, keep the trailer locked securely. And it has to do all of this while controlling a trailer that can weigh more than 80,000 pounds. That's heavier than several elephants combined. The crazy part is that all this weight is controlled through one locking mechanism smaller than a car tire. Which sounds almost impossible. Why is it called a fifth wheel? The name actually comes from old horse wagons. Long before modern trucks existed, wagons used a rotating platform that helped the front wheels turn smoothly. People called that rotating platform the fifth wheel. When engineers later designed heavy trucks, they borrowed the same turning idea. Even though modern fifth wheels look very different, the name stayed. Today, it's one of the most important systems in transportation. The kingpin, the small part doing all the work. Now here's where things get interesting. Underneath every trailer is a thick steel pin called the kingpin. This kingpin slides directly into the fifth wheel when the truck backs underneath the trailer. Inside the fifth wheel are giant locking jaws made from hardened steel. Once the kingpin slides in, the jaws clamp around it tightly. Now the trailer and truck become one machine. That small pin is suddenly responsible for controlling tens of thousands of pounds. And somehow, it survives. How doesn't it break? The answer is engineering. The kingpin is made from extremely strong forged steel. This isn't normal metal like you'd find in household tools. It's specially designed to survive massive pressure, twisting forces, vibration, impacts, constant movement. The steel is heat-treated to make it incredibly tough. And unlike weak metal, it can flex slightly under pressure instead of cracking instantly. That flexibility is extremely important. Because roads are rough. Every pothole, bump, turn, and brake movement sends force directly into the fifth wheel. Without flexible strength, the metal would eventually snap. The trailer is constantly moving. Most people think the trailer stays perfectly still behind the truck. But it doesn't. When a truck turns, the trailer pivots around the kingpin. The fifth wheel acts like a giant rotating joint. Without this movement, turning would be impossible. Imagine dragging a 40-ton trailer around a tight corner without any flexibility. The tires would tear apart. The frame could bend. The trailer might even tip over. That rotating design is one reason the fifth wheel is so important. Why it's covered in grease. If you've ever seen a fifth wheel up close, you probably noticed something disgusting. Grease everywhere. That thick black grease is there for a very important reason. As the trailer rotates, massive steel surfaces slide against each other. Without lubrication, the friction would create extreme heat, metal wear, cracking, surface damage. The grease reduces friction and helps the fifth wheel survive millions of miles. Truck drivers and mechanics constantly re-grease the system because neglecting it can become dangerous very quickly. What happens during hard braking? Now imagine a fully loaded semi-truck speeding down the highway. Suddenly traffic stops. The driver slams the brakes. At that moment, the trailer wants to keep moving forward because of momentum. That enormous force pushes directly against the kingpin and locking jaws. The fifth wheel suddenly experiences incredible stress. But somehow it holds. Modern trucks are designed with advanced braking systems to reduce this pressure. They use air brakes, trailer brakes, anti-lock systems, brake balancing. Without these systems, the trailer could push too hard against the truck and cause something called a jackknife accident. That's when the trailer folds inward like a pocket knife. And it can be catastrophic. Why fifth wheels rarely fail? Considering the insane amount of force involved, it's surprising how rarely fifth wheels actually fail. That's because engineers massively overbuild them. Even though trucks may normally haul 40 tons, the fifth wheel is designed to survive much more. Manufacturers test them under brutal conditions: freezing cold, extreme heat, repeated impacts, heavy overloads, millions of movement cycles. Some fifth wheels survive over 1 million miles of hauling. That's enough to circle Earth many times. Weight distribution is everything. Another reason the system survives is proper weight distribution. Truck loads must be balanced carefully. Too much weight pressing on the kingpin can damage the truck. Too little weight is also dangerous because the trailer can sway violently. Drivers must balance the load correctly so the pressure spreads safely across truck axles, trailer axles, suspension systems. The fifth wheel. Improper loading can destroy tires, damage suspension, and increase accident risk. Air suspension saves the truck. Modern semi-trucks also use advanced suspension systems. Many trucks use air suspension instead of traditional metal springs. Air suspension acts like a cushion. It absorbs road shock before it reaches the fifth wheel. Without suspension, every pothole would hammer the connection directly. Over time, those repeated impacts could weaken the metal. That's why suspension is critical for heavy hauling. What happens if the trailer disconnects? One of the most dangerous situations in trucking is trailer separation. This happens if the kingpin isn't locked correctly. If the locking jaws fail or the driver connects improperly, the trailer can detach while moving. A loose trailer at highway speed is extremely dangerous. That's why truck drivers always perform a tug test. After connecting the trailer, the driver gently pulls forward to make sure the lock is secure. Drivers also inspect the locking jaws visually before driving away. Because one mistake could cause huge accidents, destroyed cargo, highway shutdowns, serious injuries. The fifth wheel handles forces from every direction. Most people think the fifth wheel only supports downward weight. But actually, it experiences force from almost every direction. It must survive pulling force, sideways force, twisting, bouncing, vibration, sudden impacts, forward momentum. Imagine trying to hold onto a giant object while it constantly shakes, twists, and slams around. That's what the fifth wheel experiences every single day. Extreme conditions. Semi-trucks operate in brutal environments. Some drive through desert heat, snowstorms, icy roads, mountain highways, muddy construction sites. The fifth wheel must continue working in all these conditions. Cold weather is especially dangerous because metal becomes more brittle in freezing temperatures. That's why engineers carefully choose materials that resist cracking even in extreme cold. Heavy haul trucks are even crazier. Standard highway trucks are already impressive. But heavy haul trucks are on another level. Some specialized trucks transport giant bulldozers, wind turbine blades, industrial generators, massive construction equipment. These loads can weigh hundreds of tons. To handle that weight, heavy haul trucks use reinforced fifth wheels with extra thick steel and larger locking systems. Normal truck systems would instantly fail under those loads. The science of metal fatigue. Even strong steel can weaken over time. This is called metal fatigue. Tiny microscopic cracks slowly form inside the metal after years of repeated stress. That's why truck companies constantly inspect fifth wheels for damage. A tiny crack today could become a catastrophic failure later. Preventative maintenance is much cheaper than a highway disaster. Why engineers still use this design? You might wonder, why not invent something newer? Because the fifth wheel already works incredibly well. It provides strength, flexibility, stability, secure locking, smooth turning, Sometimes the simplest designs are the best, and despite modern technology, the core fifth-wheel design has remained almost unchanged for decades. Because engineers got it right the first time. Final thoughts. The next time you see a semi-truck on the highway, look closely behind the cab. That greasy metal plate may not look impressive, but it's one of the hardest working mechanical systems on the road. It survives enormous weight, constant vibration, harsh weather, sudden braking, millions of miles, all while safely controlling loads heavier than most people can imagine. And the craziest part, most people drive past it every day without even noticing it exists. That simple part pulling 40 tons without braking. It's not magic. It's engineering.